Hey everyone, in today's video we're going to be talking about percent of change and percent error. Now this is something that you can use to calculate how the price of something has changed over time. So if you notice like gas prices fluctuate a lot, you can use it to calculate change, or even over time like we're going to see in our first example. I know you use percent of change a lot when you get into certain science classes. So I always tell my students, even if you don't think you're going to use percent of change, I know you need it when you get into certain types of chemistry and stuff. It's not my specialty, so I can't give you more detail than that. And to compare, like we're going to do here. So in 1948, and this is real, I looked this up, the average cost of a movie ticket was 36 cents. Wow. Today, and this is a couple years old, the average cost is $9.26. Wow. What is the percent of change in the price of a movie ticket from 1948 to today? So we're going to do that in just a minute, but let's talk about percent of change for a second. So percent of change, here we go, is a change in a value, an amount, okay, something numerical, something quantitative that compares the change in the old or the original. So in the original value to the new or current amount. You may not be looking at current amount, but whatever the new one is. So you're looking at whatever the original was, you're starting, you're old, and you're looking at the new. So your equation, in words here, is your new value minus the old, or again, might be original. Sometimes you'll see it as initial, like the starting value, and that is going to be over the old or the original. There we go. Okay, and you're going to do that, and then whatever your answer is, you multiply that by 100 to get your percent. Okay? All right, so I'm going to scroll a little bit for you here. So, whoops. Uh-oh. You guys need to stay up there. Not there. All right, hang on. Let me give it a second to lock into place. Sorry about that. There it goes. All right, so if the change is positive, then the percent of change is if the change is positive, the percent of change is an increase of change, right? So it's going to be an increase in your would have gone up a certain amount. So like the movie ticket problem, we're looking for a positive percent there. Sorry. If the change is negative, then it is a decrease of change. That means it went down. And that could be something like maybe the population of a town is decreasing, right? So that would be a negative percent change. Or the amount of, I don't know, sheep someone owns. I'm not sure why that's the example my brain came up with, but that's where we're at. Okay, so let's start with that question that we started with. So I need a little bit of info. So I've got 36 cents to 9.26. So I start with the new. So 9.26 minus the 36 cents over the 36 cents. Okay, we're going to find out what that is. We're going to multiply that by 100 once we figure it out. 9.26 minus 36, so that gives me 8.9 over 0.36. So divided by 0.36. So that's 24.72 repeating. And then I take that and I multiply that by 100. Okay, because that was from up here. Multiply that by 100. So that is 2,472% is your percent of change, and that is an increase. Okay, you could tell it was an increase because I went from 36 cents to $9 and some change. So it is increased by 2,472%. That's a lot. We're paying a lot to go to the movies, and we didn't even compare popcorn. Whew. Popcorn's expensive at the movies. All right, let's do this practice here. So go ahead and pause it. Try to set it up if you can. I'm going to go ahead and do it now. So we're going to find the percent of change from 73 degrees Fahrenheit to 40 degrees Fahrenheit, and then state if it's an increase or a decrease. So I've started at 73 and I've gone to 40. So my new one is 40 because that's my most current one, minus the old one, 73, divided by 73. So if I've gone from 73 to 40, I'm looking for a decrease. So I'm anticipating this to be negative. Okay, and sorry, don't forget when we're done, we're going to multiply by 100. I'll write that right there so it's not so confusing. 40 minus 73 is negative 33 over 73 times 100. So divided by 73 gives me negative 0.45. I'm just doing this in pieces. 2 times 100. I'm going to cut it off just so I don't have to carry my whole decimal the whole time. So that is negative 45.2%. So you can say that is a 45.2% decrease. Okay, so if you use the word decrease, you don't need to take the negative with you because the decrease shows me, like, okay, it decreased. That was a negative number because it's going down, right? This negative is just how you can show the decrease without writing the word decrease, right? So one or the other, don't do both. Don't say negative 45 decrease because then the two negatives would cancel out. Don't do that. Okay? All right, we'll do Marty and her llamas, or his llama, sorry, Marty. And then we'll do percent error. All right, so Marty has a llama farm and he's living his best life. And I wish I was you, Marty. I wish I was. He had 4 llamas, but now he has 7. Happy day. Find the percent of change and then state if it's an increase or a decrease. Automatically, we've gone from 4 llamas to 7. It's an increase. He's increased his happy little farm. So he's gone from 4 to 7. So it's going to be the new one 7 minus the old over the old. Maybe they're baby llamas. I like llamas. All right. So we have 3 over 4. Oh, and don't forget your times 100. That's just moving the decimal over 2 times, so you may not need to write that part. Just remember, it's a percentage, so we need to move our decimal over. So that is going to be 0.75 times 100, and that is going to equal 75%. Okay, and that's positive, so that's going to be an increase. Okay, and notice when it's positive, I don't write a plus. I don't have to because I know it's an increase. Okay. All right, there's Marty's llamas. All right, now percent error is when, like, you guess that something, like here's an example. Let's just look at it as the example or what it is. So Alvaro estimates that there are 2,000 candies in a bowl, but there's actually 2561, excuse me. So we want to know what was the percent error of his estimate. How off was he in his guess? So sometimes you'll see percent error when people are doing different studies and different statistics. Say there may be a percent error here or there, which is similar to this. So more on that. If you're interested in statistics, you can find more info on that. So percent error is your measure of the difference between an expected value or amount and the actual value or amount. So what we're going to do is it's going to be your actual. You want to draw that big bar. Actual minus expected. Okay, over the expected. Okay. And then times your 100%. Okay. Those 2 bars are absolute value. Okay. If you don't know what that means, that's okay. All it means is whatever is inside these 2 bars, positive or negative, I'm going to make it positive. So if it's a negative, you're just going to drop the negative sign. because it's absolute value. Absolute value measures distance, and we can't have negative distance because we're not time travelers. Are you? Sorry, it got a little weird. All right, so let's look here. Let's look at Alvaro's question here. Por Alvaro. All right. So there are actually 2,561 candies in this bowl. He guessed there were 2,000. That was his expected. And that's over 2,000. Okay, I'm going to put that in my absolute value bars. Okay, times 100. If you have a calculator that can do absolute value, it might just say ABS, A-B-S. And that can calculate it for you too. Or you can just do that by hand, because it's going to be 561 over 2,000. That's already going to be positive. I really only would see a change in my problem if I ended up with something negative, which I believe will happen in a couple of problems coming up. So 561 divided by 2,000 is going to be 0.2805. Again, there's my absolute value bars. However, they don't do anything for me here because it's already positive. So really it doesn't change anything. It does show me I'm measuring some sort of distance from actual to expected. All right, and so this is going to be 28.05%. Okay, so that was the percent error because he was off by about 500 candies. So that's going to be about 25%, a little bit more than that, right? So 28.05% error. Okay. All right, let's do the same for Lupe, and I think I have a couple more. Okay, we can't really see the next one. All right, so let's do Lupe's. Go ahead and pause it, and you try it. I'm going to set it up, though. So she thinks that a bagel has 350 calories, and there's actually 245. So what's the percent error of her estimate? So the actual is 245 minus 350 over 350 inside my bars times 100%. You can put the percent if you want to, you don't have to. All right, I've got 245 minus 350, which is negative 105. So notice this is gonna, my absolute value bars are gonna help here, times 100. Okay, so that's gonna be 350 divided by 350. This is gonna be negative 0.3 times 100. Now because it's a negative, that's actually just positive 0.3. Once you've made it positive, take the bars away. They've done their job. It is an operation. So then we have that times 100. So you get 30%. Okay, that was her error, was 30%. Percent error, 30%. Okay, a couple more and then we are all done. All right, yeah, here you go, 2 more. So try number 2 and number 3, pause it. Be careful on number 3 with your units. Convert everything to ounces. All right, number 2. Kaylee estimates that the soccer stadium can seat 150 people, but it actually seats, 162. So what's the percent error of her estimate? So the actual 162 minus the expected 150, absolute value bars, times 100. Okay, and you may notice, hey, I don't really need absolute value here. It's going to be positive already because the actual amount is bigger than the expected amount. All right, so that's going to be 12 over 150. I'm going to go ahead and drop my bars because I know that's going to be positive. You can carry them with you if you so choose. All right, that is going to be 0.08 times 100. So that is 8%. So her percent error was only 8% because she was very close on her calculations. Okay, so a doctor estimated that a baby soon to be born would weigh 7 pounds and 7 ounces at birth, but was actually 8 pounds and 13 ounces when she was born. What is the percent error of this estimate? Okay, watch our units here. So let's make everything ounces. So 7 pounds, 7 ounces. Oops, sorry, that's supposed to say ounces. There we go. Okay, so my 7 pounds, I'm going to multiply by 16 and then add that 7. So 7 times 16, Nope, times 16, there we go. So that is 112 plus 7 more ounces from here. So this 7 is here. This 7 is here. Okay, so plus 7. So that's 119 ounces. That's what this is. So that's 119 ounces. And then we're going to do the same thing for 8 pounds, 13 ounces. So 8 times 16 is 128 ounces. And then plus that extra 13 is 141 ounces. Okay, so we want to make sure that everything is a cohesive unit. And with pounds and ounces, let's just make them one thing. So all just ounces. So I have my actual was 141 minus my expected was 119 over 119 absolute values times 100. Okay, so 141 minus 119 is 22. So because that is positive, I'm going to go ahead and drop my bars. So 22 divided by 119 is 0.184, and it keeps going. So times 100. So that is going to be about 18.4-ish. It's about 18% of the percent error in the doctor's estimation for this child's birth. Big baby. All right, so that's percent change and percent error. We do them together because you notice the equation is very similar. All right, that is what I have for you guys today. I hope you guys have a good one. Bye.